Okay, we're going to do limits, continuity, and differentiability. Well, I'm going to write it down. You don't, it's not a packet. It's just, I'm reviewing the content. I will save this as a PDF, and yes, so if you don't want to take notes, you can just print it out. This is all of chapter 2 and part of chapter 3. So this was chapter 2. Okay. Do you remember what a limit is? It's the y coordinate. We don't care what happens at that value. So if you have a graph here, I don't put a hole there because that bothers you. And this is my c value. So we write the limit as x approaches c of f of x. It's asking you what is the y value getting close to, but we don't care what happens at that value. Is what is it getting close to? What's it getting near? And that we'll call that L. That's all a limit is. And when you put in numbers, you always substitute first. Always. So you could print this out in color, by the way. Substitute first. Even on the free response questions, I graded one year, and they had to actually write in 0 over 0 to get your credit. If you didn't do that, you didn't get the points. Even though you might be doing it in your head, it doesn't matter. You have to write it down. Okay, remember there are 4 things that can happen when you substitute in that c value. You could just get a number. You know that's not going to happen, right? You could get a number, a 0 divided by a number. And what's 0 divided by a number? It's 0. You could get a number divided by 0. What happens there? It's a vertical asymptote. And so we're going to say undefined. And that's okay. I've seen that on the exam when they say undefined. It's either going to be plus infinity or it's going to be negative infinity. The problem is if you choose the wrong one, and it's negative infinity, you choose positive infinity, you're going to get the point taken back. There is no slope. The slope is undefined because it's a vertical asymptote. When you do these, they're vertical asymptotes. So when you are looking at like y equals 1 over x, remember what that one looks like? That looks like this. And these are also, you can't even, what is the limit of 1 over x as x approaches 0? It's undefined. Well, if I break it into sides, then I at least can tell you which way it's going. So if limit as x approaches 0 from the right side of 1 over x, what's that going up to? That's positive infinity. But from the left side, and that's why I'm recording both my classes, because the questions may be different. X approaches negative of 1 over x is going to go to negative infinity. So when you plug a number in or substitute a number in and you get a number divided by 0, it's a vertical asymptote. Well, that's still not the one that's interesting. The interesting one is the last one where you get 0 over 0. Okay, guys? Shh, Scott? 0 over 0. Some of you want to say that's undefined. It's a hole in the graph. We got a problem when you get 0 over 0. And this is one where you don't stop. I still have seen some of you say 0 over 0 and you leave it at that. No, you have to do some work. And I'm going to show you a way to do the 0 over 0s. That way? Or other way? Oh, okay. I'll show you. I'm going to give you L'Hopital's rule. The problem is, to do L'Hopital's rule, you must always get 0 over 0 or infinity over infinity. It does not apply any other time. I don't teach you L'Hopital's rule in the beginning because you'll apply it when it doesn't apply. Okay. This is indeterminate. Let's do some problems. That's all limits are. And we don't have the horizontal asymptotes. Like, let's put those in. No, I'll do this in a second. I'll keep my notes straight. Okay. Move it up. So let's do some examples. We have the limit. This is one we had to memorize of the sine of x over x. Keep that straight from this one. The limit as x goes to infinity of the sine of x over x. They're not the same. And even I have fallen into the trap of thinking it's this one without reading carefully. This is x going to infinity. But when x goes to 0, do you remember what that value was? Not 0, 1. Okay, so that's one you got to know. Now, this one, if you just think, these are thinking problems. You have to, if you saw these packets, there's too much to memorize. There are some things you have to memorize, but there are some things you don't. The value of the sine of x is never going to be bigger than 1, right? Or smaller than negative 1. No, it's trapped between 1 and negative 1. Right, because as x gets really, really big, this is going to 0. Does that make sense? The worst this is going to be is 1. 1 over a trillion is going to be, in effect, 0. Okay? So you got to read them carefully when you're doing that. Now, there's another way to do this, and it's called L'Hopital's rule. L'Hopital. No, I didn't teach it to you because the only time it applies is when you get 0 over 0 or infinity over infinity. There's other cases you'll learn about in BC Calc. You don't need anything beyond this. So if you substitute in, see, if I put infinity here, sine of infinity is, I don't know what it is. There's no value, and that's infinity. So I can't use L'Hopital's rule. But I must have 0 over 0 or infinity over infinity. So let's look at this limit again. As x approaches 0 of the sine of x over x. This is where, if this were free response, but this is not going to be free response for you guys because L'Hopital is not on your part of the exam. It's a BSET. That's the name of the French mathematician who discovered this. Oh, you'll remember L'Hopital. Everybody does. Because this is such a nice little rule. Okay, you guys over there? You can use it. Yeah, well, it has to be these. So let's see, is this 0 over 0 as x approaches 0? Yes. Sine of 0 is what? 0. X is 0. So this is what I'm saying on a free response question. If you were going to find this limit using L'Hopital's rule, you must write the 0 over 0 or you don't get credit. And then what happens here, so if you have the limit of f over g as x goes to some value, it doesn't matter. L'Hopital's rule says you can take the derivative of the numerator and the derivative of the denominator. So you're basically looking at the slopes at this place, that the limiting value of the ratio of the two functions is the limiting value of the derivatives. You're going to like this one. So what we're going to do is we're going to do L'Hopital's rule. You don't have to do that, but everybody does. And we're going to take the derivative of this, not the quotient rule. I'm just going to look at the ratio of the two slopes. What's the derivative of the sine? Cosine. And the derivative of x is 1. Now substitute in 0. Do you remember the derivative of cosine? It's 1. Just gives you another way to do these problems. Carter, put your phone away, please. You would have to do this. And then, yeah, you wouldn't only have to say L'Hopital's rule. You could do this. Where you're going to use this is going to be multiple choice. Because let's get another example. So this is the limit as x approaches 2 of x squared minus 4 over x minus 2. What do you do first? Put in the 2. What do you get when you put in 2? 2 squared minus 4, that gives me 0, and 2 minus 2 is 0. So I can use L'Hopital's rule. If you get a number divided by 0, nope. If you get infinity over infinity, you can also use L'Hopital's rule. So I just like to write that. So it's the limit as x approaches 2, and all you have to do is take the derivative of this. Do you remember how we did this in class? Remember how we factored this? Yeah, we factored it. This was x minus 2, x plus 2 over x minus 2. And remember, we don't care what happens at 2. So as long as we're not at 2, we're not canceling these zeros, but that's where your 0 over 0 is. And then you substitute 2 in and you get what, 4? Well, let's use L'Hopital's rule. What's the derivative of this one? Because it's really nice. 2x, and the derivative of the denominator is 1. What's the answer? 4. It's easy, but you can only use it when you get 0 over 0. That's a derivative of a quotient. This is a ratio of the derivative of the numerator to the derivative of the denominator. Basically, you're looking at the slopes of the two curves, and it gives you the limiting value. Proving that is not so easy. Okay, David? Put your phone away, please. Pardon? Because that's, you take the derivative of the numerator and the derivative of the denominator. Let's do this one. Let's try another one. I don't know if you remember this one. Does anybody remember this one? That one we didn't use as much. That should be 0, but we'll see. Can I use L'Hopital's rule? Put in 0. It's 1 minus the cosine of 0. And if I need to review the trig, I will, over 0. And don't forget, I'm here in the morning, so if you want to come in and just work on problems in the mornings. Mr. Dahman may be here after school, so we're covering all of our times. Hopefully. I'm not sure exactly what we've planned on that. Okay, what's the cosine of 0? 1. So 1 minus 1 over 0. L'Hopital's rule applies. So I'm going to not do the quotient rule. I'm going to take the derivative of the numerator divided by the derivative of the denominator. What's the derivative of the numerator? What's the derivative of 1? 0. By the way, if you had to do this and you mess up your derivative, you would actually, if you wrote this, the derivative with respect to x of 1 minus the cosine of x, that tells the reader that this is your plan. So if you get the derivative wrong, but you clearly say, I'm finding the derivative like that, you will still get partial credit. But if you do the derivative wrong and you don't tell them your intention, because that's what that's doing. No, because it's not the quotient rule. We're taking the derivative of the numerator divided by the derivative of the denominator. It's a theorem. Proving it's hard, so I never prove it. So what's the derivative of 1? Because I've seen this on the VC exam. A lot of students put down 1, but it's 0. Well, they didn't declare that they were going to find the derivative, and we can't assume anything. So when they wrote the wrong derivative down, I mean, we know that's what they're doing, but if they had said that's what they're doing, they would have gotten partial credit. So they didn't get anything. So it's going to be 0 plus the sine of x, that's right, over 1. Plug in 0, what do you get? No, the sine of 0 is 0. Yeah. And I remember this one. I can prove this one with a little trick. So the ones with the square roots, you remember those? I wouldn't do L'Hopital's rule of the complex fraction. It applies, but then that's tricky to take the derivative. What about the square root of x minus 2 over x minus 4? I think I've got that right. As x approaches 4. Do I get 0 over 0? Okay, I had to make that one up. Okay, so I get 0 over 0. Always write that down. That's why when we taught it in the fall, we said always write that down, that it's 0 over 0. Because sometimes it's not. Sometimes you can just take the limit. But, yes. I don't have numbers on here, and I just made that one up. Okay, so let's take the derivative of this. And remember how to find the derivative of the square root of x? Because it's x to the 1/2. Do you remember how to do that? It's 1/2 x to the what? Negative 1/2. And the derivative of the denominator. So we're going to use L'Hopital's rule. So it's the limit as x approaches 4. And this is going to be 1/2. And x to the negative 1/2 is the square root of x in the denominator. Is that okay? It's algebra. Is that okay? No? The negative sign means that it's 1 over 2 x to the positive 1/2. And that's 1 over 2 square root of x. You got to ask me. You got to say, I don't get that. Then I'll do it. I don't want to waste your time if you know that. And what's the derivative of this one? It's 1, isn't it? Yeah. Plug in the 4, and it's 1 over 2 square root of 4, which is 1/4. Mm-hmm. Help me with questions here. I don't know that they're necessarily on the exam. If you found some on the exam, give me one.
I don't have the numbers, but I just want to be sure because we don't know if this exam is going to have the same.
Good. Well, they have a lot of similarities. That's why they don't release it. Yep. And I remember that problem. I know it's 1/4. Okay, ready? Okay. Here is a limit. I would write this down. You must know. Whoops, must. No. And maybe somebody knows this. Some of you are going to look at this one and say, well, x is going to be 0, so that's 1. Okay, guys? No. And 1 divided by a very small number is getting very large, and 1 to any big, large number is going to be 1. Not true. See, this isn't 1. It's close to 1, but it's not 1. It's a little bit bigger. So this one's being pulled towards 1. That's going to infinity. So it's like 1 to the infinity. You can't do that. And if you look at your graphing calculator, proving this is tricky, I could do it, but not today. That, anybody know what it is? A special number.
No.
It's E.
Oh,
Okay, so that one you need to recognize on the exam. Oh, I don't know if I like that one. Okay? Now, what has to be true for a limit to exist? Do you remember this? Excellent. For a limit to exist. And there's value in writing this down, even though I'm going to print, and you can print it out. The limit from both sides has to be the same. C from the left of f of x has to equal the limit from the right. Okay? If you are asked, and they did this in 2012 on the free response, I think they asked about continuity or limits, I'm not sure which, but you had to say that. Okay? How did you get that? You have to say. You actually have to calculate from the left, calculate from the right. Don't assume that we can read your minds, because we can't. We have 500,000 exams to grade. So there's no way. 500,000. There's 850 graders.
How many will you have to grade?
You know, I've never kept count, but it's 8 hours a day. You start at 8, you're done at 5. No, they do give us a lot of food.
Wait,
Okay, risk investment, that's roughly 5.
8? Yeah, it's a lot of, but it's interesting. It's really interesting.
That's 588 exams in the front. Doesn't matter, we still have 4 problems, right?
Maybe.
I think we would.
Okay. Now let's look at the asymptotes.
Never.
So if I do this on the heavy credit AP side,
Yeah.
I come in early every day.
Yes. Okay. No. No, I cannot grade your exams. I've never had that happen. And we never grade more than one question for a student. So we have folders, and we have a number. You guys have a number. We have a number. We write our number on the side, and I have gotten folders that I had already graded. So then I have to turn it back in and say, no, I've already graded this one. I can't grade 2 problems from you. Well, it's to be fair. Okay, vertical asymptotes, that's the limit as x approaches some value, c, and that's going to be plus or minus infinity. Just to give you a picture, because I think that helps. So this would be a vertical asymptote here. Okay? It's either positive infinity or it's negative. It's a break in your graph. Can the function cross a vertical asymptote? No.
That's why it's called an answer.
No. It's because you won't have a function. Is that a function now?
No.
Not a function. We can graph those things using parametric curves, parameters, which you'll do in BC. You can graph those. When you do the vertical asymptotes, you must check from both sides. You need to do the limit as x approaches c from the right of f of x, and you have to do the limit as x approaches c from the left, because they may not be the same. You may not even have a vertical asymptote on one side. It may only be on one side. Okay, ready? You could have this situation, I've seen this, where the graph comes in like this, and on this side, it's a vertical asymptote. It's an exponential function that gets you that. It does happen. So there could be a vertical asymptote, but just really from one side. Now, a horizontal asymptote. That's asking you to describe the end behavior. We are going to do the one out of 2008, the one that they didn't count. I was really surprised that they didn't count it. Because they kind of, curve it, more or less. This is the limit as x approaches positive infinity of f of x. And you must find the limit as x approaches negative infinity. Well, that's what happened in 2008 on number 19. Now, I don't have it in front of me, so I'm going to go grab it. I'm planning, at least. There it is. So number 19 was thrown out. Are you going to open your packet or just trust me? I don't know what you wrote, but it said, what are all the horizontal asymptotes? By the way, can a function cross a horizontal asymptote?
Wait.
That way?
Wait, so both ones you just wrote are vertical asymptotes?
Those are vertical asymptotes.
No, it cannot.
Those don't exist, both are vertical asymptotes.
Does from the left. At the right, no. I know, you're trying to think of what function would do that, but there are some out there.
So when you solve,
Yes.
what would be the question? What would be the answer?
This one, it would have to ask you from the right and left. What's the limit from the right? Infinity. Limit from the left is 0.
And then the upper one is
From both sides, they're going to positive infinity. Because I put that in there to show you that that's not a function. You cannot cross a vertical asymptote. Can you cross a horizontal one? Yes, Alex.
I need to cut my table so if you get these
Okay. Okay. Can you cross a horizontal asymptote? Pardon?
He's taking my table.
Can I cross this horizontal asymptote?
No.
Yes, I can. The reason you can't cross a vertical asymptote is you don't have a function then. That's the only reason. And you have to have the same limit. It doesn't ever get there. Even though it crossed here, but it's the limit as x goes to infinity. So let's look at this one on, I don't know what page 30, it's number 19.
On what path?
This is 2008,
Give me a moment while I take the guys.
number 19. This was what you took on Monday.
It's somewhat, yeah, I'm not gonna dig through all this.
Okay. It says, what are all the horizontal asymptotes for that graph? The problem with this one is, many of you probably selected A, because that's one of the answers. So you didn't look any further. I think that's why they threw it out. It isn't the only answer. If you read through all the questions, all the answers there, there's more. There's a better answer. Mhm. Okay. Okay, you guys. We're a little behind. Now, there's a number of people that are going to be gone tomorrow, correct?
Yes.
No? Okay, guys. Let's do this problem. Let's let x go to positive infinity. You know what I do? Now, this is an exponential. Some of you have learned, okay, guys? Some of you have learned about, I don't know, you learned some weird thing about HOV or whatever. Forget it. Just think about it. Oh, well, you weren't in that class. So that's good. Now, as x goes to infinity, what's going to happen here? Okay, Carter. If x goes to infinity, do we really worry about the 5 and the 1? No. So it's going to look like 2 to the x over minus 2 to the x, which is negative 1. So the equation for that asymptote is negative 1. That's answer A.
What if it has 3 to the x or 2 to the x?
Then it would be 3 halves, right? If it's 3 to the x.
Yeah, it'd be 3 halves to the x.
I remember this one that you taught me.
Okay, shh. You guys. Okay. When x, okay, girls, when x gets really large, the 5 and 1 don't matter. I have $5 and I have another couple million. I don't really care about my $5. Okay, shh. Yes. It did. I'm like to finish it, and I'll show you why. No, it was thrown out. Not graded at all. Okay, I know. I was surprised at that. But Mike, shh, let me say this again. This is answer A. So what happened, my guess is, that students picked that one up right away and went on. You must look through all your choices. Don't assume when you find the right answer in A that that's the right answer. Look through them all and make the best choice. It's not right. Because when x gets big, like trillions, I don't care about the $5 or the $1. Who cares? This is really going to look like 2 to the x over minus 2 to the x. Those are the same things, except it's with a negative. Now, let's go to negative infinity. This one's trickier. Now, what I'm going to do is actually put in some numbers. And you know what? You can do that too. You could do that on the first one. These are all thinking. That's not done. When you find, okay, you guys, if you listen, you'll get this right, because I'm pretty sure it's going to be on your multiple choice part of your exam. Because they've made a point of saying the teachers need to teach this. When you do horizontal asymptotes, you must look at both positive infinity and negative. It's not the same. And if you don't believe me, put on your graphing calculator and take a look at it. These are horizontal. Horizontal asymptotes. You're looking at end behavior. Now, I'm going to put in numbers. Should we let x be negative 100?
How about negative infinity?
It's too hard to think about. So it's going to be 5 plus 2 to the negative 100 over 1 minus 2 to the negative 100. Now, what does a negative exponent mean to you? It's a reciprocal. It's really 1 over 2 to the 100. Agree? And that's what this means. 2 to the negative 100 means 1 over 2 to the 100. What happens to this other one? What happens to these guys?
What happens to that? They cancel.
They're 0.
Yeah, they're.
So what's the horizontal asymptote? 5. That is answer E. Because you have to have both.
Wait, we can't answer.
I think it's E.
I don't have the packet.
Well, I don't need it. Mine's over there.
Okay.
Ignore the H.
Not, this is negative infinity. Positive infinity, yes. Put in some numbers.
Does that mean the limit just
Make
doesn't
this,
exist then because it doesn't
Andrew, put this 2 to the 100 over 1 minus 2 to the 100. That doesn't matter. But this does because that's a negative exponent, which means 1 over 2 to the 100th.
Alright.
Missy, I'm gonna take my partner test. Can I take it today during like my lunch?
Yeah?
Okay, so at noon.
Yeah, it's in there.
What's the test? Do you remember?
I think it's 2611.
One moment.